Hi everyone, in this video I'd like to show you the computer generated image of this rational function. I'm pointing it here, and as you see, that's number 3. It's also plotted, which is the constant function. If you think about it, that's going to represent some horizontal line. So it turns out this one is a horizontal asymptote 3, so I'm comparing it with this horizontal asymptote. So this is going to attach to my other videos in this YouTube series. So learn how to do how to find all the end behaviors of vertical and horizontal asymptotes and all that to sketch the graph of this function. And pause the video. You may try yourself to sketch the graph of this function. Then I'll show you whenever you're ready that how it actually looks like. So here it's what's showing, and because it has a quadratic in the denominator and the discriminant of this denominator as a quadratic expression, discriminant is positive, so we have two x-intercepts, not x-intercept, I'm sorry, x vertical asymptotes here and there. Then if you calculate x-intercept for this one, which is coming from the numerator being 0, and you will find that this numerator never be at 0. Therefore, as you can see, there's no x-intercept. The difficult part, when you actually just use the end behavior and x-intercept and y-intercept, because we do not have x-intercept here, it's kind of, you probably have to test a couple more points to get a form behavior around what's happening in the middle part and that part. So this horizontal line is where y equals 3, and that's supposed to be the horizontal asymptotes, and this line here is a vertical asymptotes. And as you can see, the graph actually crosses horizontal asymptotes one time, but once you cross it, it doesn't cross it anymore. So to the right, eventually it never crosses horizontal asymptotes, but it's getting closer like this. If you use a low resolution computer software, this part is very difficult. Not computer software, the calculator, this part is kind of hard to see. It kind of looks like just a flat, as if it is just coming down like this. But if you look closely by zooming in, you'll be able to see this part and going below like this. And that part also, we get this end behavior and that end behavior, and knowing that it does not have x-intercept, kind of turns around and go to the other direction like this. So this is a reasonable behavior with the information that you find, namely the end behavior of vertical and horizontal asymptotes and x and y intercepts. And but just to make sure, you might test a couple of points in here and there. So as the last thing, I'm going to zoom in, kind of exaggerate by rescaling these y-axis. Going to exaggerate this going down and slowly coming back up phenomena with a bit of exaggeration. Okay, what it's shown here is that I changed this y-axis part, zoomed into 2.7 and 3.2. So scale you see in the y-axis is a lot smaller than scale you see in the x-axis, which runs from -2 to 20. So this is a lot of vertical stretch around y equals 3, so that it kind of finally shows that it actually crosses that horizontal asymptotes and make this little local minimum behavior and comes back up to try to stay below, right below y equals 3 and become an horizontal asymptotes. So that's the behavior to the right. Thanks.